And let's go to the other reactions. We have finished the nucleophilic addition reaction, that is under it A protonation, B N alkylation. Next is electrophilic substitution reaction. Electrophilic substitution reactions. So you know already with respect to the electrophilic substitution reactions, electrophile reacts with the electron rich species. Electrophile is an electron deficient species which reacts with the electron rich species. Here electrophile reacts with the electron rich species. Which electron rich? Pi electron rich species which are present in the pyrazole. So this is the pyrazole. So always I told you in the electrophilic substitution reaction the pi electrons are involved, that is the pi bond or the pi electrons are involved. So it reacts with the electron rich pyrrole. Electron rich pyrrole behaves as the nucleophile here. And what is the first electrophilic substitution reaction? It is nitration. And here the simple nitration mixture which you will write it for the benzene. Pyrazole reacts with nitration mixture H2SO4 and HNO3 to form pyrazole. Sorry, this is the product obtained. And one important thing, always electrophilic substitution reaction happens at the fourth position for the pyrazole. Already this I have discussed with respect to the pyrrole, furon, thiophene, pyridine. What for everything there is a one reason why it is behaving like that. For this also just check the slide PPT slides which I have forwarded to you. Based on the resonance structures, it shows that the more stable product is formed only when the reaction happens at the fourth position. Why? Because the electron density is more at the fourth position when compared to the third or fifth. That is the reason. So when you can see the pyrrole, only these positions are free, that is third, fourth and fifth. When compared between third, fourth and fifth, the electron density is more at the fourth position, which is shown clearly by the resonance structures which are there in the PPT. Please once you go through those resonance structures and you can easily understand why the fourth position is more favorable for the electrophilic substitution reaction. That you no need to mention it in the exam if until or unless there is a question why the electrophilic reaction happens only at the fourth position. Till that you don't need to mention, just write fourth position is favorable for the electrophilic substitution reaction in the pyrazole because the electron density is more at the fourth position. Electron density is high at fourth position. Which electron density? Pi electron density. Okay, next reaction is halogenation. Under halogenation there are two reactions. A, iodination. So iodination, very well. Pyrazole reacts with iodine and hydrogen peroxide aqueous. This is the reagent. Pyrazole reacts with aqueous hydrogen peroxide in the presence of the iodine. So you know the position 4 is favorable. 1 2 3 4. This is the product obtained. Simple. 4 iodo pyrazole is obtained. Pyrazole, in the presence of iodine and aqueous hydrogen peroxide, forms 4 iodo pyrazole. This is the iodination. Next is bromination. It is bromination. So the reagent is important. This is the pyrazole reacting with the NBS, N-bromosuccinamide. Already I have discussed this N-bromosuccinamide. If you remember what is N-bromosuccinamide, I have discussed. Please check your notes, previous notes for the N-bromosuccinamide. This is the brominating agent, and in the presence of heat, okay, we need to heat it, and the product obtained is simple, same 4-bromo pyrazole. This is the product obtained. Pyrazole reacts with N-bromosuccinamide under heated temperature. When certain temperature is given, the product obtained is 4-bromo pyrazole. Always the electrophilic substitution reaction happens at the 4th position because of the high electron density at the 4th position. So N-bromosuccinamide, already I'm just giving the explanation about this NBS reagent, brominating reagent. Succinic acid, you know, N-bromosuccinamide. Succinamide means you have to remember the succinic acid. Oh my, such good apples, I've already told. Oxalic acid, malonic acid, succinic acid, glutaric acid and adipic acid. Oxalic acid is COOH, and when you go on adding CH2s, you will get the remaining acids. So oxalic, malonic, succinic, COOH, CH2, CH2, COOH. This is the succinic acid, N-bromosuccinamide. So this is the succinic acid. So N-bromosuccinamide. So how we will get this N-bromosuccinamide? So one of the hydrogen is going to is eliminated to form the amide, that is CONH, and the other is going to get eliminated by the bromine. So this forms the N-bromosuccinamide. Okay, so CO, this H will be replaced by the NH, and this, as CO is already present, COO, this H should be replaced with the NH amide, and one more H with the bromine. So we will get the N-bromosuccinamide. Just refer the structure from the mentioned topics. Next, after this, here this finishes the electrophilic substitution reactions. We have discussed 2 reactions. One is iodination and the other is the bromination. And next comes the other reactions, oxidation and the reduction. So oxidation, you know, oxidation is always addition of the oxygen and the elimination of the hydrogens is always called as the oxidation. So in the case of the oxidation, we are using a special reagent, that is substituted pyrazole. That is, you can see this is the substituted pyrazole. What is it? 1-phenyl 3-methyl Pyrazole, here we have used this reagent in the presence of the oxidizing agent potassium permanganate. You know, KMnO4 is a very good oxidizing agent, right? So this substituted pyrazole 1-phenyl 3-methyl pyrazole. First position